Greetings, this is Artie from Artifact Electronics. So you're looking at my latest patient. It's an Alesis Quadracent, early 2000s. They had several different models with different size keyboards. This was the flagship with the 88 key piano style hammer action keyboard. Plays back ROM samples. Has 16 megabyte of samples. Hundreds of programs and presets, and I'm not exactly sure what they do yet, but the manuals are all available for this. And it also can distribute, it's multi-timbral and can distribute it all over 16 different MIDI channels, so you can create some pretty scary music with this. Anyway, this item did have some inadequacies, or defects I should say, which allowed me to get this for around $100, which is a really good price for this, even though it's pretty old. But you're still getting the full keyboard, and another good thing about it is this thing weighs over 50 pounds. And when getting something like this shipped via eBay, it inadvertently gets damaged because it's packed improperly and all of that. So on heavy things like this, I would always prefer to be able to buy them locally. Let's have a look at the rest of it. Here's the back view of it. So it does have two PCMCIA slots stacked on top of each other here, and those will basically allow you to save sounds. Or you could buy ROM packs from Alesis that would expand the sound set. We have a serial port that's switchable between PC and Mac. 3 pedal inputs. 3 MIDI jacks. Digital in and out. Sound outputs. And headphone inputs. And that pretty much sums up the back. One issue that's a bit worrisome is that this was missing several screws that held the top panel down. I mean, it's all loose because somebody took it apart and tried to do something in it, gave up, threw it together, put in 2 screws, and was able to push it off on the pawn shop owner. And but it's a good thing because that's the way I got it. So let's have a look at the defects. Well, let's go ahead and turn her on and see what happens. So powers up, but I can immediately see that the LCD is, well, not on its last legs, but I mean it is missing 2 rows and a few columns on the left. And it also, you probably can't see this in the video, but it looks like it's not mounted correctly. The right side of it seems to be drooping, and it is not straight in there. I haven't been inside this yet, so I don't know, but I suspect that was the reason why this was taken apart, because somebody tried to fix it but was unable to. Now, trying out sounds. So the sounds work. I did try a few different sounds. And what else do we have? Strings. So, makes sound. And if we go back to the piano again, I immediately find one key that has velocity problems. switch sides here. So one of the keys needs looking at, and I hope that's the key contact. And whatever other surprises I'll be presented with once I remove the cover. So let's try doing that. I took the top cover off, and here's a view of the motherboard. Well, it's the motherboard, but it doesn't have any children. It's basically, this is it. This is all you get. Starting off with our transformer, which looks pretty small to my eyes, proven by a primary fuse of 1/4 amp. And then we're basically looking at a bunch of, let's get a little bit closer on this. So we have a bunch of ASICs here. A ROM, a through-hole ROM battery. Looking over on the other side, a bunch of DRAM over here. Connectors running to the front panel controls. And this is the LCD connector right here. And that goes to the LCD. The angle's bad, but if you look at it straight on, this thing is not sitting in here correctly. It looks slightly askew. So what I'm going to have to do is do a continuity check on this cable, see if everything goes in. Now, I did some initial checking on the internet, and it turns out that this, the pinout on the LCD is non-standard. There's some pins are swapped, and I have to sit down, map it out before I'll be able to put a different LCD in there and see what that's going to look like. Other than that, what else can we see? We can see the PCM-CIA slots over here. And one other thing to note is that it looks like a tasty, refreshing beverage was spilled right over here, causing a bunch of corrosion and rust spots, which needs to be cleaned off. And other than that, there's the keyboard. And there really isn't anything else in here. So probably a good place to start would be the LCD cable, but since we're at it, let's have a look at the battery. And the way I'm going to measure the battery is there's an SRAM sitting right over here, which is battery powered. So let's go in and see what power that shows us. And if at all possible, it's always better to measure it at the chip to see what power is actually going in there. 2.8 volts, which is more than sufficient. So the battery's good. You don't have to mess with that. But let's take out the LCD assembly and see what that reveals. So I've removed the LCD from its mounting bracket, and it's a plastic mounting bracket with 4 tabs that it's supposed to snap into, and it wasn't snapped into them properly, so I was kind of hanging askew there. But I thought I'd take it out. I did a continuity check on the ribbon cable, and the ribbon cable tested good. I checked solder joints on it, that looked good too. And what we get now is this. This is completely different. Now it's showing garbage. At least last time it showed the proper thing, but now it's gone bananas. And changing presets just puts up different garbage or nothing. So the first thing I need to do is find out exactly what the pinout is and see if I can adapt an LCD that I have to this pinout and see if that'll work. So it turned out a bit confusing to figure out exactly what the pinout is. There were two different schools of thought about how to do this, and so what I did, I took a display first of all that if I burned this up it wouldn't break my heart, to test out if I was able to figure out the pinout correctly. Now notice that on the original one the connector is on the side where my thumb is, but the test one I'm using has the connections across the top. So first I thought I'd have to make a kind of a crossover cable that adheres to the pinout of the newer LCD, but that turned out to be quite a pain in the neck. So then I thought, to test it out, why not wire it directly to the through holes on top to at least test the theory, make sure that things show up correctly, and then find an LCD that actually fits into the plastic holder, and I'll most likely wire it directly, just like this, and use copious amounts of a hot glue to insulate things. But let's have a look at this. So this one comes up correctly, and so I can change things around. I can change banks to something different. So at least I figure out the proper pinout, how to get it connected to the motherboard. And the next step comes in now trying to mount it mechanically into the old plastic holder and then back into the top panel. So let me go and go through my collection of LCDs and see what, if anything, I have that would fit physically. I went through several LCDs I had, and this one looked to be the most likely candidate because it has the side connector. But it turns out that the width of the metal frame is a little bit wider than the original, so it wouldn't fit into the bracket. It would have required a lot of sanding and cutting of the original bracket, which I didn't want to do. So what I did end up with is it turned out that the prototype I made actually does or did fit. During fitting it, there are 4 tabs, here, 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 and here. This tab broke off and flew off. I don't know how that happened. Maybe it had been weakened before, but I made up for that with some hot glue over here, making up for that tab. I also hot glued all of the connections, and the other end is simply a 14-pin IDC connector where the red stripe indicates pin number 1. One other reason I use this is in order to get the backlight to work, it's not internally connected. You have to connect it to power and ground, which are the last 2 pins. This one, and normally you shouldn't connect it straight because it'll wear out the display. You need a limiting resistor, or a dropping resistor, but it turned out that this actually had the dropping resistors already on board, which are between these pins and the actual anode-cathode. The anode and the cathode connections on here. So that worked out well. Now, looking at the other side, here's the plastic piece with the window. This was scratched up pretty badly, so I cleaned it with an acrylic or a plexiglass cleaner, which I'll show you in a minute. But basically this will fit right back into the instrument, and It looks like the frame, the black frame isn't showing through on the edges. It's centered pretty good, so that when it's back in, we'll see what it looks like when it's in the instrument. Now, the product I use for cleaning it is called Novus, and I'm familiar with this product because I've used it on pinball machine playfield parts quite a lot. It comes in 3 stages. You basically start with stage 3, use 2, and then the one I showed you before. It's available through suppliers of pinball parts and that, but wherever you are in the world, anything that clears up scratches on plexiglass should work just fine on this. Here it is plugged into the motherboard, and seems to work well. And we can change things, and I think they meant to say French accordion. Either that, or they came up with a new instrument called an accordion. But what do I know? Here's a connection map I promised, but first, big disclaimer. LCDs don't always have standard pinouts, as we already found out with the OEM display they were using in the Alesis that was non-standard. But other displays may have things mixed around, so what I'm showing you works for the specific LCD display that I got. I got it years ago from a Chinese source, so I very much doubt that you can get an exact replacement. But be aware and be careful, because one thing that I found is on most LCDs, if you swap ground and 5 volts, it will blow out the LCD. And I have several to show for that. The only time that isn't true is if you get a fancy display like this VFD display over here. It costs like $48 or something. At least they are nice enough to, let's even zoom in on that. They are nice enough to install a fuse, which I don't know if you can see or not, but it is clearly marked. There's a surface mount fuse right here. And that fuse has, for me, saved several of these displayed when they were inadvertently plugged in wrong and the supply got reversed. But that's not something you're going to find on the Chinese specials. And also let me add that you can buy, I've seen that you can buy a plug-and-play replacement for the display. The original display costs between $50 and $60, and if you do a Google search you will find it. To me that was out of the question, because at that point that would have been half of what I paid for the whole instrument, so I did have to find a cheaper solution. But now let's get back to the map here. So as it turns out, pins 1 and 2 go straight through. They are correct. However, every following pair of pins is swapped. So as you can see, 3 with 4, 5 with 6, and so on and so forth until 13 with 14. And as long as you have the ground and power pins connected correctly, I don't think you'll really hurt anything, because all that happens is the data lines will get messed up and you'll either won't see anything or you see garbage, but you won't hurt the display. We then get to the backlight, which is pins 15 and 16 on mine. The anode is on pin 15 and gets connected directly to pin 2, and the cathode is on pin 16 and gets directly connected to 1. And again, as I mentioned, on my display there already was a dropping resistor before power reached the backlight, so we didn't have to insert one. Now, one special thing, and this little box is optional here. Pin 3 on the LED, on the LCD, is the contrast adjustment. What I did on mine is I just connected it to the contrast voltage coming off of the Alesis board, and as you saw before, the contrast was just fine, so I didn't mess with it. But what may happen is that whatever LCD you use, you power it up, the backlight comes on, but you see no characters displayed. And I'm not talking about blocks or anything, but rather nothing is displayed, and that is usually an indication that your contrast voltage is off. Excuse me. The way to fix that is to insert, and I didn't write this down, a 10K pot. You can get a small pot and probably hot glue it to the back of the LCD in any convenient spot. Q1 and Q2 are hooked up to the top and bottom, doesn't matter which ones, and the middle connector goes to pin 3 on the LCD, and this acts as a voltage divider, and you basically adjust the pot until your characters appear, and they're easily viewable from whatever angle you prefer. So you may want to pause the video and do a screen grab of this in case you ever attempt to do this yourself. The next step was to remove the keyboard, and I found it easiest to lay it upside down with the case attached on the ground, remove all the screws, and then lift the bottom case off. And that basically showed us the inside of the keyboard. Now I had to remove these contact PCBs. They were held in place by these braces like this, which all got removed. Then there were several screws holding the PCB to the keyboard assembly, which were also removed. And then you can swing it up and remove the contacts and have access to the actual PCB contact as well as the membrane contacts. Now what I'm going to have to do is go through this and with isopropyl alcohol clean the contacts on the PCB and the contacts and the membranes, and that'll take a while, but now you know what I'll be doing for the next 45 minutes. So cleaning the membranes is done and everything's back in place. I also found one of the keyboard to PCB connectors had cracked and had lost the top, so the wires were beginning to fray off. I replaced that. It's blue. The others are black, but it's the same, it's the right size. And then yet another thing I found was the keyboard, and we're looking at the bottom of the case here, has these felt spacers that are supposed to go under every screw hole, and there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 11 of them, but there were only like 5 or 6 of the felt spacers in there. So if that keyboard got tightened down a lot with those missing spacers, it's going to deform the keybed. So I'm going to have to replace the missing ones, but rather I found these furniture leg protectors, and what I'm going to do is drill a hole through the middle of them. They're about the same height as the old ones, and stick them all over the holes so the keybed sits evenly with a spacer on every screw hole. The last thing to address is the corrosion here. I'll see what I can do about it, but I played around a little bit with it already and it's very difficult to remove. It's probably going to require a total strip, i.e. I have to sand down that part of the bottom of the case and repaint it, because as you can see there are other traces of it flowed all the way over there. I'll probably just clean it up for now as best as I can and put that on the to-do list for the next time that this guy's open. But now let me go ahead, put in the spacers, and replace the keyboard. One more thing that needed to be done was to take the slider assembly off the top panel, remove all the surrounding plastic pieces, and do three things. One, blow it out with compressed air to get all of the dirt and fuzzballs out of it. Number two is use your favorite contact cleaner to spray the inside liberally. Work the sliders up and down several times, all of them, and then place this upside down on a paper towel like this and let it sit for a few hours. That way all of the extra contact cleaner will drip out, be absorbed by the paper towel instead of running into the instrument. And last but not least, I gave every slider a brief squirt of fader lube so they move a little bit smoother. And once this is all dried up, I will wipe off the PC board and it'll go back into the front panel. I put it all back together, and one final word, even though I may be repeating myself, is if you try to replace the LCD, you're on your own. Just make sure that you read the data sheet of the LCD you're inserting. And the most important part is that pin 0, as supplied by the Alesis, is ground, and pin 2 is VCC, or 5 volts. Make sure, measure them with a meter before hooking up a new LCD, and the other signals should just fall in line. And again, LCDs don't like their supply voltage reversed and will punish you by dying very quickly. There's quite a lot to be discovered in this keyboard. It has 500 presets, including a general MIDI bank, and it also has the concept of a mix, which can be used to turn this instrument into a multi-timbral sound module, because you can now combine programs, assign them to different keyboard zones, and assign each one of those to a different MIDI channel. So with the help of a sequencer, you can create some scary music with this. Now, there's way too many presets to go through all of them and give an analysis, both because of the time required, and second of all, I haven't done that yet. I'm going to have to spend at least an afternoon going through all of these presets and evaluating them, and maybe that'll be covered by a future episode. Now again, there's many presets, but I stumbled across this one, which coincidentally is a Hammond simulation, and it sounds pretty good for a sample playback instrument. And here it is. We should never neglect the pianos, and what we can do is use the piano to find out if after cleaning the keyboard we actually achieved velocity consistency across the keyboard, and I think we have. So let's try that one last time. I think I misplayed that one, but it sounds pretty even. 88 keys is a lot. It's been a while since I've played a real piano. But here we are at the end. I hope you enjoyed it and maybe even learned something about how to get your Alesis quadrasynth back to life. So go ahead and subscribe, because we got lots more good stuff coming up, and maybe even a thumbs up if you liked what you saw. See you at the next episode.